When React Native was first announced nearly 10 years ago, it had a very simple premise, and that was web the good parts. And from this basic concept, React Native has grown to become the most impactful framework for building client-side applications today. If we fast forward to now, React Native powers hundreds of apps in the App Store trending list every single day. And there's no signs of slowing down. So where do we go from here? I'm Evan Bacon, an engineer and the creator of Expo Router. Expo Router is the first file-based framework for building apps that work on both web and native at the same time. By simply creating files in the app directory, you can instantly create robust navigation for both your native app and website. It uses familiar web APIs like a link and href to push between screens. And it's also a nested router, enabling you to organize routes into shared folders to create elements like tab bars, headers, drawers, which work across children routes. And of course, the best part has to be that it uses native primitives, like a UI navigation controller on Apple devices. So your gestures and your animations are all feeling truly native because they are truly native. There's no way to tell that it's not native because it is native. And starting day one, we have access to the React compiler, thanks to collaborating with the Meta team. This means that you no longer need to write use memo or use callback in your applications, which is pretty sweet. So a lot less code. Things are just truly declarative, leading to a much better experience for both web users and developers alike. We'll be installing this in Expo CLI in the next version of Expo CLI when it comes out. So pretty sweet. If you haven't seen React Compiler yet, I highly recommend checking it out. But anyways, there are many attributes to building native applications, and Expo provides solutions to most of them. But all these solutions are primarily targeted at client-side applications. And there's only so much that you can do with the client on its own. Things get really interesting when you start to involve the server, when you bring in data fetching and server rendering. From a data perspective, most native apps operate essentially like single-page websites. This means there's slower performance and substantially less networking, right? Everything is happening on the client. Nothing else is happening on the server. Now, popular native apps such as Lyft, Netflix, Reddit, so on and so forth, all use some form of server-driven UI in their production applications today. And it's very complicated. It's super hard to set up, to configure, to design, and as a result, it's out of reach for most developers in most types of applications. Now, they do this so that they can A/B test and render different UIs with a high degree of variation. This is based on all sorts of things like criteria, such as user type, location, the currency. They want to render different UI based on different criteria of the user. And the approaches all vary in many small ways, but they do share some common architecture, such as using JSON as semantic UI representation. Think of this like HTML, but for custom native apps. Now we can see a pattern here. Server-driven UI is an important system for building apps, and it's just very inaccessible to indie developers. So what if we could make server-driven UI available to everyone, but also the most powerful version of it ever imagined? That's the goal of Expo Router. To do this, we're bringing React Server Components, the most cutting-edge approach to server rendering, to all platforms through Expo Router. This is a huge undertaking, as it will require reworking many different libraries throughout the entire universal ecosystem. Everything needs a couple refinements, ranging to a ton of refinements. But our official implementation of RSC for universal apps is currently in early development. However, it is worth sharing the progress that we've made so far at Expo, because it's frankly pretty exciting to see what server-driven apps are capable of. Now, there's a lot to RSC, such as server actions and concurrent routing and flights, etc. But I figure it'd be easier to just show you guys what's possible in the form of a demo that we built at Expo. Now, I've been really interested in AI lately, just like everyone else on the internet. But it's historically been pretty hard to build high-powered AI native apps. And this is because streaming and server rendering are both critical aspects of working with an LLM. But with React Server Components and Expo Router, it's actually really, really easy to build AI apps. as I'll show you here. So here I have a ChatGPT-like app, which pings OpenAI via a React server action and streams in native text from the server. Everything that returns back is at least partially server rendered. So we can ask it a question like, should native apps be server rendered? Which is a great question to ask it. And then, of course, it'll return something back like, native apps are typically not server rendered. Native apps are developed using whatever things. And that's because, this is not something that people have traditionally done a lot. Or when they do, they don't talk about it too frequently. Now, to create the server action, we have another file which defines use server inside of a function, this send message function over here. And when we call send message, which is fully typed, it essentially is doing what an API route does. It's making a network request to this code, which runs on the server. And then we wrap it in suspense. The suspense basically tells the connection to stay open until the promise resolves, which means you can have asynchronous components inside of it. And then down here, we have an asynchronous function, recursive text, async React components, pretty sweet. And then we can incrementally, recursively render through the text to render out all of our elements. And that's how we can create this effect right here. Now, one novel aspect of Expo Router's server environment is that it's a multi-platform server. Now, what this means is that when we call send message from an iOS device, even though it's running on the server, it knows to render the iOS version of React Native Text as opposed to the web version or Android versions. So you essentially have like kind of a dimension of platforms, matrix, a lot of complexity. But it actually feels pretty sweet. And this is just the basics. We can scale this concept up to any native UI. So let's do something a little bit more exciting. When React Native was first demoed, they showed a truly native movies app, and you had like push animations. You could scroll through it. It was so neat. So I thought it could be fun to pull movies into this prototype somehow. For inspiration, I looked at what the state-of-the-art, best possible AI apps had to offer. In ChatGPT 4, when you ask for movies, it renders a bulleted list of Markdown, some text here after it searches Bing. Cool. I also tried this with 4.0, and it's just a little bit faster. And on Google Gemini, it does the same thing, but with images and links. What we're seeing here is that this is just Markdown. With Expo RSC, we can do a lot better. Here, we can match any query to search for movies, send it up, server render views, stream them back down with native UI menus, links, elements where we can then server actions to recurse back into it, find more actors, and then it requests another server rendered element, pulling everything down from the client. All these movie cards are rendered on the server. We can even interact with native APIs by doing like create an event. This will server render a calendar card, which then can access the calendar permissions and then create an event. So pretty fucking sweet. Oh. Overall, way better user experience with a lot less reading, but even more exciting than this cutting-edge developer experience, user experience, is the developer experience, because it is the same format as what we did with the text. We're just using views and images because we have RSC, this semantic representation of our views. So here, we have a suspense boundary to show a skeleton loader while an async component fetches data and then renders the movies and streams them down. It just makes sense to look at. It feels great. It's awesome. And then to add the interactive elements, because you can't have interactions on the server, those need to run on the client, we can mark a wrapper component with use client, which means that just this one boundary gets split out and executed on the client. That code is bundle split out and loaded over the air when you want to interact with this component, when it mounts. This is what enables all of these different interactions where you have things like menus and touchables and so on and so forth. So it's really easy to step between the two boundaries, between client and server, using this directive. Because after we jump through all of the hoops required for server rendering, and trust me, there's lots of hoops, we aren't just rendering to the DOM. Like, we get to render to truly native views, as if the app were built with first-party tools like Xcode and Android Studio, because you will be using Xcode and Android Studio as well. It's kind of like how you do today. So it's progressively rendered, best practices, it's truly limitless. You get native scrolling. Just there are no limits on this. You get the best of web and all the power of native. But the best part, by far, has got to be that it renders like this on every single platform. We write this once, and it runs everywhere, mostly because I'm using a lot of base primitives like view, image, and text, and loading image and like animations, so these especially work well across platforms. But because we're pulling a lot of our logic out and moving it to the server. So anything related to network requests are truly universal because the server is it's agnostic to what the platform's doing. Now, this is the part where I will attempt to live demo the app that I just showed you. The Wi-Fi is spectacular in here. So we'll just go ahead and give this a shot. All right, yeah, you can see my computer here. Great. Let's connect to the hotspot. Oh, man. All right, and then right here, I have Expo CLI running. So you see, whatever. And what I want to do is I basically want to show you guys the dev server running with my phone here. This is my phone. And so you can see the client and the server as it's recursing back and forth between the two. So here, this is a development app, an Expo app. We will connect it, and we'll see how it goes. So opening it up, here in the background, you can see we're loading in all the flight chunks, all the asynchronous bundles, and we have our app. So just like in the demo, we can list some new movies, press that button, recurses back to the server, comes forward, starts rendering the suspense, and we can see data fetching in the background. I mean, so the big chunk is when the data loaded in, right? Over here, just like before, we can long press to select, and here you see that there is actually a server action, which is then recursing for more data, and then fetching. So I'd like to say that we have timers to emulate the production environment and how that latency will work, but the Wi-Fi is just doing that automatically. So let's find, you go challengers, create an event just like in the thing. There we go. We can render out the views, but we can also do other things. This is so easy. I demoed part of this last week, and in the last few days, I just took all of the input that people had given about what we should add to the prototype, and I just built it in, because it's so easy to use, and I was really struggling to demonstrate that in the talk. So I just wrote a bunch more parts. So here we can say, show me some classic Polish music. And now what this is going to do is ping the dev server and then render down a Spotify card. And we can log into Spotify. This uses Expo Auth session. Log in right there. Oh, man. Everyone look away for just a moment. Perfect. Logs in. Oh, man, it's just like you get to see all the states. Here we got all of our Polish music then streaming in. We're able to just encapsulate all of this logic, everything required for Spotify authentication in a single component, including the secret handshake that is required to get a long-lived token. Never before been anything quite like it. But we can do a lot more than that too. So let's look for, let's say, show me things to do in Krakow. Now it's going to ping the dev server back here again, any moment now. And then it will ping Google Maps. So we see it loading here. We can see the animation as it's coming through, pinging Google Maps. There's all the Google Maps data in the background. And now we can slide through a native map component. So even though this content was server rendered, it was able to stream down to the client where we can render a native map on top of it. And then also look at just how much data is loaded in the background here. So RSC is automatically optimizing our requests by converting it into the minimal amount of RSC code required to stream down. So I think if we weren't doing that, the network requests would be a lot slower. So we can come in here, and we can, let's see, we got this cathedral. We can select it, and then we can get the weather in this area, ping it back, render us down a weather card. That's pretty sweet. We can also book an Uber over here. Oh, I do have the weather set to Fahrenheit. We could switch that over to Celsius. I know how you guys like that over here. And we're still booking the Uber. We have the Uber here. We could request the Uber. opens up the Uber app just like that, and I've got an Uber to the location. What is that, PLN 18? I don't know what that means. So we can ask the, let's see, convert 18 PLN to USD. And then it will probably stream back an answer telling me how to convert it. You know, $4.50, that's nice. But what about all these other numbers in here, like 22 and such? Well, here's where things get really interesting. So I don't have a card to just dynamically convert PLN to USD. I didn't create that card. But the number one piece of feedback I got was that, you know, since all this is running on the server, why don't we just have the AI write the elements, just write the code, and then render it and stream it down. So I'm going to go ahead and try that live for the first time here, and we'll see how it works. Create a currency converter component. And now what's going to happen here is that this is going to ping OpenAI, and it is going to generate the component for us. So there's no guarantee that the component will work. And it you know, it's a nice venue to have code just error out on stage. But there it is. Look at that. It's pretty sweet. We haven't tried it yet. We don't know if it works. So what are some of these numbers? I mean, they don't have to be exactly, but 22, OK, 22 PLN convert to USD, $5.50. So we do have it working. And right up here, we can see the actual code that it generated. This is React Native. It's universal code. It wrote all of this code for us. This code doesn't exist in there. We can scale this out in any direction we want to take it. So we could also say, show me the locations as a to-do list. You know, because I wrote this locations map thing with like Vegas in mind, and it doesn't work in Austin, like we just have flat buildings. So a different form factor is better. So here now we have a to-do list. So it's fully interactive. Like we have, OK, we have checkboxes. I said it was fully interactive, then I remembered it might not be. Yeah, here we've got Expo checkbox. We inform it of which libraries in the SDK it can use before it generates the code out for us. So yeah, just like that. And then we've got all of the locations from before. So that is the iOS part of the demo. We can just switch back over. I mean, like we got the dev server. It's pretty good. We have the dev server running right here. This is Expo CLI. We just hit the W key and launch it right into the web. So, you know, same deal as before. We could say list some new movies, and it'll launch the movies. The craziest part is that I didn't have time to really thoroughly test that UI generation in the cloud thing. So I have not tested that on all platforms yet, but we can just try it here. One idea I had was, what if we create a chat UI component and see how this does. We'll take a second. I mean, I didn't have enough time to add the loading indicator, you know, like the skeleton, or maybe you watch the code stream in, because it streams in all the code first, and then we evaluate it. So then it would look, you know, a bit snappier, because we are getting instant response. But looks like it is making some progress there in the background. What is this progress? Oh, OK. So we've got a little chat UI here. We could say, hello, App.js conf. That's pretty sweet. I can't believe that. It's crazy that this is working. I mean, it's not. I planned this. Obviously, this all works. Like, and of course, use Expo. So, I mean, how does it even know to use my photo there? Like, it generated this code here in the background. Like, it's OK. So it has like my GitHub profile in there. I guess it like knows. Maybe I've like informed it. But then, yeah, here's all the code it's generating back here. Incredible. All right, let's switch back over to the keynote real quick. So that is what it looks like when we take the modern state of server rendering and AI and then bring them universally to every platform with Expo Router. We are seamlessly gliding between client and server in a fully typed file-based framework for the first time ever. You only have to configure complex APIs for one platform, and that's the server. Waterfalls and parallel requests are all taken care of for you automatically. Because this isn't just some rinky-dink server rendering system we have in here. This is React server components. This is the best that the web has to offer, running universally on all platforms. Secrets are secured automatically. Static client code is automatically, it's removed from the bundle. We can SSG code. In fact, this code has the RSC requests pre-built at build time and embedded in the bundle. Meaning if we start this app in airplane mode, I probably should have did that when my phone was linked, then it just fires up instantly. The only time that you would actually hit a network request or interact with the server is when you're going to interact with the server anyways to make a fetch request. So it still feels truly native, very snappy at a component level. Tons and tons of new benefits, too many to go into, just redefining what's possible with our mobile devices and enabling new types of apps to be built in record time. Now, the app you just saw is running Expo SDK 51 React 19 in new architecture. We're still actively developing the server renderer part that adds use client and use server, and then the part that actually deploys the server. So if we move fast, we can have an early beta out maybe by the end of this year. But just to be safe, we'll say 2025. So consider this an RFC. Is server rendering something that you want to see on native? I believe so. I love using the system. I can't believe I was able to get all that stuff working in the last few days. So the future is very bright. I'm Evan Bacon, and this has been Universal Server Components in Expo Router. But there is one more thing that we'd like to announce today in the Expo team. So to do that, please join me in welcoming Cedric Van Putten to the stage.
Expo Router has been our most ambitious project yet. And it was clear for us from the start that traditional tools weren't going to help us build it out. So we built new ones. Introducing today, Expo Atlas. Expo Atlas is a tool to visualizing and understanding your Expo bundle output. Right from the start, it gives you a complete overview of all compiled modules within your app. With this, you can easily spot really big ones or relatively large ones, like this one, Lodash. So where can we go from here? How can we see where it's imported, and how can we resolve it? So to do that, we can just click it. For the first time ever in React Native, you now have both the import and output source code for any modules within your whole project. And it doesn't just end there. With this, you can easily trace down where certain dependencies are imported, or how it's being imported, and especially why it's being imported. Now, let's get rid of that Lodash real quick. So there we go. Unlike traditional source map explorers, Expo Atlas updates right away. So you can try different optimization approaches without having any distractions at all. Going back to our bundle overview, we can easily spot that we just shaved 600 kilobytes from our bundle just by verifying where certain dependencies are being imported. Now, Expo Atlas has helped us tremendously. Internally at Expo, we believe that this tool has been fundamentally crucial for all of our projects. It helped us build out universal React Server components. It even helped us out create the new Metro resolver, which is up to 6 times faster. And it also required us to add support for nanoseconds formatting to Expo. It won't help your app have smooth animations, though. But it does help you iterate faster at scale, which in turn enables you to move faster and build better user experience. So try it out today. You can try it out in any SDK 51 project using this feature flag. You can also wait for the release blog post, which should be up later today or tomorrow on expo.dev.blog. And we can't wait
to see how you will use Atlas. Thanks.